Hello everyone, welcome to Math World. This video is to discuss binomial expansion for paper 3 and this is the part 1. So basically we will start with the notes first. Okay, so the formula for this binomial expansion in paper 3 is 1 plus x to the power of n, and the formula is 1 plus nx plus n minus 1 over 2 factorial x squared, plus you can just extend this expansion until infinity times. So this is the fourth term plus until infinity. Okay, and this formula or this expansion is valid when modulus of x is less than 1. So this modulus of x is basically, we get it from here. Alright, so generally we will be using this formula when the n is real number. That means it is any values. Alright, so this is the formula from this binomial expansion of paper 3. Okay, so let's move on to the example. So first question is, find the first 3 terms in the expansion in ascending powers of x for this term, stating the set of values of x for which the expansion is valid. Okay, so first of all, when we compare, so compare this formula or this term with the formula over here, our power is real number. Okay, it is a fraction, so 2 over 3. And then from here, I will be writing 8 minus 3x to the power of 2 over 3. So since this is real number or real degree, therefore we need to make sure the first term must be 1 in the formula. So which means this can be done by factorizing 8. So when I factorize 8, it should be 1 minus 3 over 8x. And all of these terms with degree of 2 over 3. Okay, then from here, now when we need to use the formula, make sure we have plus. Alright, which means now this minus should belongs to the 3 over 8x. So what we need to do now here is, I need to write, okay, 8, 1 plus negative 3 over 8x as one term, then all this with degree of 2 over 3. And at the same time, since now here we have 2 terms, see here, first term and second term with degree 2 over 3. So I will be using another formula which is AB to the power of m, that is A degree m times B degree m, which means you bring in the degree, okay, or the index, what we call as index. So now here I will be getting 8 to the power 2 over 3 times 1 plus negative 3 over 8 x to the power of 2 over 3. Okay, then from here I will just do expansion. So in ascending power, so we need first 3 terms. Now 8 to the power of 2 over 3 is basically 4. Okay, you can just get it from calculator. And then now when you compare, which means now this x in the formula becomes negative 3 over 8x. Okay, so you just replace accordingly. And of course, replace the n by 2 over 3. So from here, you will be getting 1 plus 2 over 3, this is our n, times negative 3 over 8x. This is my new x, plus, so here I get first 2 terms. So we need 3 terms. Therefore, another term is just use the next formula. Okay, that is 2 over 3 times 2 over 3 minus 1, that is negative 1 over 3. Then over 2 factorial, multiply with negative 3 over 8x, and then you square it, followed by the rest of the terms. Okay, then from here, I will just simplify the terms inside the bracket. So it will be 1 minus 1 over 4x, and then minus 1 over 64x squared. Alright, then from here, okay, lastly, you can just do expansion. So multiply this 4 into the square bracket. That means you will be getting 4 minus x minus 1 over 16x squared. So these are the first three terms in the expansion. Now we have done the first part. The second part is stating the x values for which expansion is valid. So as you have seen here, alright, so the expansion is valid, right, is valid when modulus x less than 1. So what we need to do is we have to take the modulus of the x provided it is plus. Alright, so now you refer to this form. Refer to this expression. So after the plus, we got to take the modulus of this whole term, and you will be getting the sets of x values for which the expansion is valid, which means, right, so from here I will write the expansion is valid when modulus of negative 3 over 8x is less than 1. And now we need to find the x values. Now we know that the modulus here is the absolute value, which means it will be always positive. So even though it is negative here, at last it will be 3 over 8x. Right, it's the same as this. And then now since we are interested to find the x, therefore the 3 over 8 can be factorized. So you will be getting 3 over 8 modulus x less than 1. Therefore, your modulus x is less than 8 over 3. So this will be the sets of x values for which the expansion is valid. Alright, so done for this first question. Okay, now let's move on to question 2. Expand 2 plus x with degree negative half. Again, the power is negative, right? Or I would say that it is real number. Therefore, it belongs to P3. In ascending powers of x up to x cubed, where modulus x is less than 2. So the x value is given. Hence, alright, so this is the first part. Hence means use the previous answer, or otherwise, when x is small, obtain the first 4 terms of the next expansion. Okay, so first of all, I will expand 2 plus x to the power of negative half up to x cubed. Okay, so again, we have to factorize the 2 so that the first term is 1. Therefore, I will be getting 2 bracket 1 plus x over 2. And with degree negative half. Okay, so with this, right, I will bring in the power first. So now here, since here is already plus, so we just bring in. Okay, so now I will be getting 2 power negative half. Then 1 plus x over 2 to the power of negative half. Okay, with this I will just start doing the expansion. So 2 power negative half is basically 1 over square root 2. And remember just now our formula was 1 plus x degree n. This is 1 plus nx plus n minus 1 over 2 factorial x squared and so on. Okay, therefore from here I will be writing 1 plus, now my n is negative half, so negative half, then x is x over 2, then plus negative half is my n, then n minus 1, so that means minus half minus 1 minus 3 over 2. And since there are 2 terms here, then over 2 factorial. And then now my new x is x over 2. Okay, so therefore we will just replace the x accordingly. So it will be x over 2 squared. Third term plus 1 over 2, negative 1 over 2, negative 3 over 2. Now, negative 3 over 2, you minus another 1. That is negative 5 over 2. And this is over 3 factorial, followed by x over 2 cubed. Okay, so that's all for the expansion. And then from here, I will simplify all the terms. It becomes 1 over root 2 times 1 minus 1 over 4x plus 3 over 32x squared minus 5 over 128x cubed. Okay, now just for information, we seldom leave our square root in the denominator. Okay, what to do is basically we need to factorize, we need to rationalize, which means instead of writing 1 over root 2 just for information. Okay, 1 over root 2 to rationalize, this is same as 1 over root 2 times root 2 over root 2. It is root 2 over 2. So we prefer this form. So that means here for the coefficient of the bracket here, it will be root 2 over 2. Okay, so lastly, just do expansion. So times root 2 over 2 into the whole brackets, which means here you will be getting root 2 over 2 minus root 2 over 8x plus 3 root 2 over 64 x squared minus 5 root 2 over 256 x cubed. Okay, this will be my expansion up to x cubed. So done for the first part. Now, second part is hence. When the x is small, obtain first 4 terms of the new expansion. So now I will write 1 minus x squared over square root of 2 plus x. So the word hence here means that you are expected to use the previous answer. So for previous expansion, we have done 2 plus x to the power of negative half. Alright, so when you look at this term now, basically 2 plus x degree negative half is the term if I move up this denominator. Okay, so that's why I will be expressing in that form so that I can just direct use the answer from previous part. Okay, so now we will just need to expand, okay, multiply with all these terms. So the first term 1 minus x squared is with degree 1, so no need to do any expansion. Okay, wait, let me, okay, I have done a mistake here. The squared should be outside the bracket, right? So sorry about that, which means now here I need to expand the quadratic and then multiply with the expansion in the previous part. So when you expand the quadratic, right, a plus b squared, that is going to be a squared plus 2ab plus b squared. This is the formula, which means now here I will be getting 1 minus 2x plus x squared. Okay, and rewrite all these expansions, or I mean all these 3 terms, or for all these 4 terms, just replace. I mean, just substitute back into the term. So, which means that is square root 2 over 2 minus square root 2 over 8x plus 3 root 2 over 64 x squared minus 5 root 2 over 256 x cubed. Okay, so then let's look at the question. We need to get first 4 terms. So just for information, if first 4 terms, which means it will be just up to x cubed. Okay, so my expansion is just up to x cubed, which means when this is 1, you do expansion, this 1 multiplied to the whole square bracket, I need to consider up to x cubed. When I consider this negative 2x multiplied to the whole brackets, I will just consider up to x squared, okay, because we just need first 3 terms. So firstly, I will rewrite all the terms. Okay, done for the 1, multiplied with the brackets. Now for the second term, don't forget, there's a minus here. So this minus 2, right, multiply with all the terms. So remember to change the signs from the plus into minus. So then I will be getting minus. Okay, now at the same time, you see there is a 2 here. So the 2 and the denominator can be simplified. So you will be getting minus square root 2x plus square root 2 over 4x squared. Then minus, so you have to change the sign and the denominator divided by 2. So 3 root 2 over 32x cubed. Okay, so I will stop here because I just need to get first 4 terms. Then next is this x squared multiply into the, or multiply with the terms inside the brackets. First 4 terms means I need to get up to x cubed. So I will stop after second expansion. So which means now here I will be getting plus, minus. Okay, the first one is plus because x squared times root 2 over 2. So plus root 2 over 2x squared. And then x squared times minus root 2 over 8. So minus root 2 over 8x cubed. Then plus dot dot dot. And the rest of the terms can be omitted. Okay, so which means now here just need to simplify. So the first term, square root 2 over 2. And then for those terms with the x, just simplify. Okay, just combine these two together and simplify it. It will be negative 9 over 8 root 2x. And then when you simplify the term with x squared, that is going to be plus 51 over 64 square root 2x squared. Followed by last term is minus 61 over 256 square root 2x cubed. Okay, so this will be the expansion, which means we do not need to redo the expansion, but just use the previous expansion. Okay, that's the meaning of the hence. All right. Okay, now let's look at the question number 3. So given fx as a rational function, firstly, express fx in partial fractions. All right, be hence or otherwise expand or obtain the expansion of fx in the ascending powers of x up to and including the term in x degree 4. So firstly, partial fractions. Now when you look at the degree, total degree of the denominator, basically it is degree 3 when you do expansion, degree of x. Okay, this is the highest degree of x, is degree 3, and the numerator just degree 1, which means this is the proper rational function. So for proper rational function, we can just direct find the partial fractions. Okay. So now I will just write 6x minus 2 over x plus 1 x squared plus 3. So the first factor in the denominator is linear. Therefore, we will be using constant over linear factor plus, now for the second term, that is a quadratic factor, but we are not able to factorize this. Therefore, we are writing bx plus c. Okay, so your numerator will be linear function. So now what to do is you get the same denominator, okay, by comparing to the left side. So I will get 6x minus 2 over x plus 1 x squared plus 3. So when you do comparison, basically the first term I need to times with the denominator of x squared plus 3 so that it will be the same. So at the same time, the numerator should be the same term, x squared plus 3 plus bx plus c over x squared plus 3. And now when you compare with the left hand side, I need to get x plus 1. I need to multiply x plus 1 to the denominator. Okay, so this is how I get the same denominators here. Therefore, I can cancel off all the denominators and just write down my numerators for my next step. So a times x squared plus 3 plus bx plus c multiplied with x plus 1. Okay, then now to get the unknowns, okay, I'm going to use the substitution method, which means I will replace the x values. You may use comparison method. Okay, that means you do expansion for the right side and then you compare the coefficients. So now I will let this factor be 0. So when x plus 1 be 0, that means your x equals to minus 1. Okay, and then I replace x equals to minus 1 in this whole expression. So I will be getting 6 times minus 1 minus 2 equals to a bracket minus 1 squared plus 3. Therefore, this is going to be minus 8 equals to 4a. Hence, my a is found. That is minus 2. Okay, now next is to supposedly we let the another factor. Okay, this factor be 0, but unfortunately x squared plus 3, it will not be 0 because x squared itself is already, least value is 0. So when you add with 3, least value is 3. Okay, therefore I will ignore this, and then now I will just replace the x by any other numbers. That means I will let it be 0 because I have px. So when x equals to 0, you can let it be any other values. Okay, but then at that time you have to solve simultaneous equations. So now when x equals to 0, the left hand side will be minus 2 because 6 times 0 minus 2 equals to a. So you replace the x squared, you replace the x by 0, it will be just 3 plus b times 0 is 0, no need to write. Then left a c, then 0 plus 1, it will be 1. Then from here, I need to get my c. So which means my c equals to minus 2 minus 3a. So now my a is replaced by minus 2. Therefore, this is going to be minus 2 plus 6. That is going to be 4. Okay, and now the next one is to get b. So which means we need to decide for another x values. So since I have used 0 and minus 1, probably now I just let my x be 1. You can use x be any other values, no problem. So now when I let x be 1, I will be getting 6 times 1 minus 2, that is 4. Then now my a, okay, a you can directly replace if you want. So here is going to be minus 2. Then x squared is 1 squared. 1 squared plus 3, that is 4. Plus b times 1, that is b. The c is replaced by 4. Then x plus 1, that is 2. Okay, then now I need to find the b. So which means 4 equals to minus 8 plus, so just do expansion here, plus 2b plus 8. So obviously the minus 8 and plus 8 will be cancelled off. So now I will be getting 2b equals to 4. So 2b equals to 4, which means the b is 2. Okay, so with this I have found all the unknowns. What to do is just replace the unknowns in this general partial fractions. So which means now here I will be getting 6x minus 2 over x plus 1. Okay, x plus 1, x squared plus 3 equals to a. A is my minus 2. Okay, here. A over x plus 1 plus b is 2, 2x plus c, c is 4, over x squared plus 3. So this will be my partial fractions. Okay, now for the parts b, hence or otherwise obtain the expansion of x of fx, including the term in x degree 4. Okay, so now let's proceed to parts b. Your fx, I will rewrite minus 2 over x plus 1 just now, and plus 2x plus 4 over x squared plus 3. Okay, just to double check. So now from here, since we need to get the expansion until x degree 4, so what to do is, I found that my x, okay, the first term, my x plus 1 is the denominator, so move up before we do expansion. And at the same time, I will change the order so that x is the second term. Okay, so when you move up, the degree becomes minus 1. And then for the second term, it will be 2x plus 4 times 3 plus x squared. Okay, just arrange first. And now, when you look at here, first term, no problem. You can direct integrate because, you can direct expand because it's 1 plus, right? But then for the second term, this is 3. So I have to factorize the 3 first, which means now here, I will rewrite and do the expansion at the same time. Okay, I mean, all the expansion will be done at the same step. So factorize the 3, 1 plus x squared over 3, and then degree of minus 1. Okay, so now they are in the general form. Therefore, we can just direct expand it. So the first term rewrite minus 2. And now here, you just need to use a formula. This is going to be 1 plus nx plus n minus 1. So over minus 1 is minus 2 over 2 factorial x squared. Just extend it up to x degree 4. So this is our expansion. Alright, minus 3 minus 1 minus 4 over 4 factorial x degree 4. Now we have second expansion, that is 2x plus 4 multiplied with this 3 power negative 1. Okay, so as usual, this power negative 1 bring in. So I will be getting 1 over 3. Okay, so I better write 1 or 3 power negative 1 first. Right, then I will have to expand this. 1 plus x squared over 3 with degree of minus 1. So again, use the same formula, but no need to expand so many terms, because when you read the question carefully, we are interested to get the expansion up to x degree 4. So once you get x degree 4, then you stop. Okay, which means now here it will be 1 plus, my n is minus 1. My x becomes x squared over 2. Sorry, x squared over 3. Then plus n minus 1, that means minus 2 over 2 factorial. Then square of this term. This is x squared over 3, another square. So when I do expansion here, right, we have another formula. A to the power m to the power of n. This is going to be a to the power of mn. So when I just expand this, this is already x degree 4, which means I do not need to get second term. I mean the third term. So I will stop here. And now what I need to do here is just do the expansion, simplify an expansion. So this is going to be minus 2 bracket 1 minus x plus x squared minus x cubed plus x degree 4 for the first expansion. Okay, then the second expansion, this is 3 power negative 1. So I will just write 1 over 3. And then rewrite the 2x plus 4. And simplify the terms inside the square brackets. Okay, so which means now here I will be getting 1 minus x squared over 3. Then plus x degree 4 over 9. Okay, so next step, just do expansion. So, right. So which means now here I will be getting minus 2 plus 2x minus 2x squared plus 2x cubed, then minus 2x degree 4. Okay, then now this 1 over 3 I will just times together. This is 2 over 3 x, right? Or probably I keep it first. I do expansion for this 2x plus 4 multiplied with the brackets. I think that is easier. So here plus 1 over 3. So firstly, 2x multiply with the terms inside the bracket. So all the terms multiplied by 2x, that will be 2x minus 2 over 3x cubed. Okay, so the 2x times the x degree 4 is x degree 5. We don't need it. So you can just keep it. Then now followed by the plus 4. Okay, this plus 4 multiplied to the terms inside the brackets. So which means now here I will be getting plus 4 times 1. Okay, that is going to be 4. Then 4 times negative x squared over 3, negative 4 over 3x squared. 4 times x squared, x degree 4 over 9, that is going to be plus 4 over 9 x degree 4. Okay, so now here I will rewrite all the previous 5 terms. or the first 5 terms. And then for this 1 over 3, it will be multiplied to all the terms inside the brackets. Alright, so here I will be getting plus 2 over 3x minus 2 over 9x cubed when you do expansion here. And then plus 4 over 3 minus 4 over 9x squared plus 4 over 27x degree 4. Okay, so lastly, just simplify. So from here, now minus 2 is a constant. Simplify with 4 over 3. Alright, so it will be negative 2 over 3. Same goes to the term with the x. So 2x plus 2 over 3x, that's all. Then you will be getting plus 8 over 3x. Okay, same method for the next term, that is going to be negative 22 over 9x squared plus 16 over 9x cubed minus 50 over 27x degree 4. Okay, so this is our expansion for fx. Right? So that's all for this video. Right? Thanks for watching. If you enjoy watching my video, please subscribe to the channel and also share this video with your friends. Thank you everyone and stay tuned for more upcoming videos. Bye.